All right, people. Hello, and welcome. Sorry for the slight delay. We can perhaps get this visual out of the way here. Sorry for the slight delay, everyone, as it always goes. When you have an appointment for something, 100 things come up right before that. But welcome, everyone. We seem to have a decent turn out today. So, as you may or may not know, I moved my live streams from the main channel to this one about a week ago. So it's been a little bit more quiet on these streams, but hopefully we can bring back some subs over time. Do let me know if my audio levels are somewhat decent. Looks pretty good here on my end, but I've been known to mess up those things in the past. So, if at any point you want me to adjust the music level or the sound levels in general, just let me know in the chat. Righty-o. So today we're gonna basically do the same thing that we did a few weeks ago on the main channel. But rather than using Odin or C3, we're gonna be doing Zig. And so I somewhat unexpectedly got access to the Jai beta just a few days ago, actually. I had almost completely forgotten that I even requested it, and figured, yeah, they're too busy shipping the game. They don't have time for new testers. So I kind of forgot about the whole thing, and then I got access all of a sudden. And if you've been following me for a little while, you know that I've been looking at various different languages lately. Partly because I just find that fun, and partly because my game engine here actually makes it semi-easy to add support for different languages, specifically like different systems programming languages, into this code base in the form of mods. And so we've been experimenting with a few of them. And so far we've done Odin and we've done C3. And of course the main code base is a mix of Zig and C++. So first of all, let's make sure that we can actually run the game here in its normal form. Yeah, we have all of the mods disabled. That's good. Let's run the game and see what we have. Right, we have some debug draw thingies there from last stream, actually, still. Yeah, I made a camera shake. Boink. Drive into something, you know, aggressively enough, you get a little bit of a camera shake going, like that. You can find that stream there on the channel as well. I think we have let's see what the master ball is actually set to. Yeah, it's very low, which is good. Good for streams, unless we specifically do audio things. I'm gonna go ahead and get rid of those debug outputs though, and I think the option to do it is here, isn't it? Just when I thought I had it figured out, I see that these are already commented out. So this is Zig. This is not what we're going to be doing today. We're going to be looking at Jai in just a bit. But before we do that, though, let's make sure the game is actually doing its thing correctly. Yeah, so it prints the impact pushes the thing to a debug draw buffer, and then in the debug draw buffer we draw a sphere and a string, right? That all looks good. So why are we actually seeing those still? There are a number of reasons why that might happen. Most of them have to do with me building the wrong thing somehow. How is that happening? Sorry about this. Kind of figured that I would have enough time to sort everything out. Seems like I kind of didn't have that today. 1810. Yeah, that looks good. Yeah, and of course we have our hot reloaded things here. Let's just get rid of all of those. And and make a full build. So immediately we see something that, you know, one reason why I want to mess around with Jai with, because making a full build with Zig on Windows, I should add, it's kind of slow currently. What was that? That was like 10 seconds or something like that. Jai tends to build much faster as far as I know. Yeah, we're still actually seeing those outputs. That's annoying. Yeah, so it's that one. Oh, strange. So we should like in theory be able to actually, you know, should in theory be able to like hot reload this thing now here. If we set that to true. And then just, you know, make that color like, I don't know, red or something like that. Lately we've actually been working on making the Zig code hot reloadable. Alright, I need to, yeah, okay. Yeah, I need to bring back all of this stuff. Yeah, we've been making it so that we can hot reload the Zig code, and that's kind of nice. Except I would like it to be much faster to actually do a full rebuild of this thing. That would make it really useful. Yeah, we're clearly like not we're clearly not actually, you know, running the correct code here now. That's peculiar. We're still seeing the orange ones. Hey, December Ray, welcome back. What's going on? Bless you to have no bugs today. We're already off to a bad start here. Like, okay. Let's see. Which version am I running? I'm running the release version. Okay, cool. Let's get rid of those libraries. If I now run this, we shouldn't be able to load the game. Okay, cool. So if I just undo all of that and get back this. Actually, let's just restart. Let's restart all of the Visual Studios here. Make sure we're not somehow using some. Oh, that's the Jai one. We're gonna get to this one in just a second. We're building the debug one, yes. For those of you who are shouting at me, you're building the wrong one. I'm actually not. I'm building the debug for use with the release version of the game. Because building a release Zig library takes even longer, mostly due to LLVM and all of its optimizing passes. Right, so is that thing actually not... Let's do this now. We're gonna get to the bottom of this. I refuse to let this thing actually mess with me. So let's do like debug bindings. So you can see this is C++ actually. Draw sphere is right here. So I'm gonna run the game, and we're gonna see what we get. Right, so here we are apparently drawing a sphere, like so. Where's that coming from? Right, so it's coming from here. We can see that we do have these enabled. It's Impact FX Player. Oh. Impact FX Player, ah. Okay, here we go. So we have two things that do basically the same thing. How annoying. Okay. Yeah, some of this code is really kind of old, so I just kind of forgotten how it actually works. Never mind then. Okay, so now if we build this, now we should get rid of those pesky debug drawings. There we go. Cool. What are the odds that I would have like the exact same debug output in two places at once? Okay, anyway. Welcome everyone, now that we have this thing out of the way. This is Traction Point. It's a game I'm building almost completely solo. I have a person making some sounds, I have a person making some music. I hopefully will have soon a person helping me a little bit with the narrative. But most of the stuff here is completely made by me, including all the art, which you can probably tell. It's not the most not the most beautiful art in the world, but I kind of like this art style, so I'm going 100% with it. The game engine is written in C++. The game is written in Zig, so it's sort of like a hybrid code base. Comes from the fact that I've had this game engine for a pretty long time, but I'm kind of over C++ these days, as kind of tend to happen when you write it long enough. The game is a DLL written in Zig, which is loaded almost kind of like a plugin on top of C++. In addition to that, we have the ability to load mods as either plugins themselves, so DLLs, or WASM modules, so WebAssembly modules. And you get almost the same API for the mod as you get for the actual game. So we can create game objects, such as this car here. If we look at this car here, we can see that it is a it's called Test Vehicle Scout 1. Its type is vehicles/scout. Right? That's a game object type name. We can see that this cliff is called Depot Level Specific Cliff 7, and this tree is probably called Spruce something, and with one Spruce Red. So these are the object names. What does an object name mean? Well, it basically means that if we go here into the asset browser and we find something called a blueprint, not to be confused with the Unreal blueprints. So if we have the vehicle here, for example, we have a file here with vehicles as a test vehicle. We have a truck, another truck. Here we have the mother vehicle. Yeah, vehicles don't have wheels here in this visualization. It might be kind of strange. Also have the Scout here, which we've just driven around in. And this guy has a bunch of components that you can set. For example, it has a transform component right here, basis dynamic body transform component, and it has like it chassis mesh here, for example. So if we expand this guy, we can see that, okay, now scout chassis bin mesh, scout chassis bin material, blah, blah, blah. And all of these components currently are either C++ components or they are Zig components. So you can mix and match C++ and Zig components freely in one object, which is kind of like well, one of the things that make this tech kind of special, I guess. These objects beginning with basis : they are C++ components, and this is just like its fully qualified name. So that's a namespace, and then that's the dynamic body transform component is the actual component name. Then we have VHL dot vehicle controller component. And this is a Zig component. So vehicle controller component, if we go have a look here in the Zig code, vehicle controller component is right here. And here we can see its registration name, which is what we just saw there in the asset browser, right? So this doesn't use an ECS. It's very much like a traditional, like if you know Unity, this would be something kind of similar to mono behaviors, where you have a component, it has some data, and it has some logic, and there's a little bit more complexity perhaps in this, because it is a client-server system, which means that you can, and the components are very much aware of this client-server thingy, so you can have like multiplayer functionality built directly into the object model that way. You can see here that we create some of these things, like the wheel renderer, for example, is only created on the client, while some other things like the dynamic body transform component is created on the client server, level editor, and asset browser preview. So if we untick this here, it will actually go away from here, which is not something I want to do, but we can, for example, just untick that one and save it, and we can see that, oh, the chassis goes away. So that's kind of that's the way that works. And what we have been doing with Odin and C3 lately is we've added the ability to actually create components that you can add from here. Mostly because it's just fun and I like exploring new languages, but also because that allows, at least in theory, people to like write mods in other languages than Zig. And so I was thinking we would try to do the same for Jai today. Alright, we have a question. Hi, how does your game loop look like? Is it iterating over all entities and their components? I mean, the answer is yes, but if you're thinking like we have a bunch of we have like a loop that iterates over the entities, and then we have a loop that iterates over all of the components in each entity. No, that's not how it works. We'll actually get to look at that a little bit later down the line, because we need to actually implement that for Jai. But basically, let's look at something that actually has like an update. So we go to one of the, let's go to the game here. Game is up here, and here we have all of the components so far. So let's say we have a, what would be a simple one? Yeah, that's a very simple one. That doesn't really do anything. Let's go to the AI driving component, for example. Again, if you've used Unity before, you know that you have things like update functions, and I think it's called fixed update. In this engine, you have an update function, which here is commented out. But if you have an update method like this, just leave that out. If you have an update method like this, you can see that this is a method because it like takes a self pointer. It will get automatically called for this thing. An update is the variable update, which means that it will get called every frame essentially. Then you have pre-tick and tick. So here's pre-tick, and there's probably a tick one as well. Yes, this one. Pre-tick is called before the physics is stepped, and tick is called after the physics is stepped. And ticking is done at a fixed rate, and it's only done when the actual game is unpaused. Which means that, like, if we unpause this thing here from the, we can debug unpause it or debug pause it. But if we go into the pause menu here, updating is still happening, ticking is not. And the way this works is that we have, well, actually, I think that's probably enough for now. I'm gonna show you just in a bit, because we need to actually implement all of this for Jai in a second. But basically, that's how it works. You do actually update the components, provided they actually want to be updated. And you know, you update all the entities that you have, or the components of the entities. The game objects themselves don't have any update functions, but their components may or may not. And a component may have an update, and may have a pre-tick, and it may have a tick, and they're all handled sort of separately. In the C++ code base, all of the components are created sort of in place in an array, such that the iterating over those components is very cache friendly. In the Zig version, it currently doesn't do that. It actually allocates the Zig components one by one on the heap. That's something that I've been meaning to change. I just haven't gotten around to doing that. And that is what we're probably going to be doing in Jai as well today. And also in Odin and C3 and all of that. But we are basically iterating over the collections of components of a certain type. And there's certain like ordering that needs to be managed, all of that. Hey Matt, you might need a video similar to the switching from WebGPU one. Explain you aren't using any ECS. May slow the pace of that question being asked. Yes. To be fair, no one's actually asked me today if if I'm using an ECS. But yeah, Matt knows that that question does come up every now and then. Well, yeah, I mean, I don't really care. I don't really care that people ask me that. They're free to ask me that if they want to. I figured I would do a little bit of an introduction today to what we're actually doing here and what this project is about. And as part of that, I just mentioned that we're not using an ECS. But yeah, anyway, that is that. So what we have currently on the Jai front, and remember here that like if we have any Jai people today in the stream, do feel free to call me out if I'm doing something stupid here, because I only really started learning Jai like 3 or 4 days ago. Don't exactly remember when. Let's get to the Jai stuff anyway. So we do have a little bit of stuff here actually written. You can see some of this stuff is actually like commented out here. This is actually like Zig code, this commented out pieces. Because I've just taken, but there's a little bit of Zig code, there's a little bit of Jai code, a little bit of everything. Mostly just because I've like copy pasted pieces from like the you know, from the same part of the code base in Zig, if that makes sense. Let's see if we can actually build this thing. We can. Cool. So we should be having we get a jaimod.dll produced for ourselves here. Let's see, we have a question, or we have a comment. I'm also working on a game in my own engine in my free time. Funny thing is, I'm comfortable with the engine level stuff, but I tend to overthink or struggle with gameplay code. I don't think that's all that uncommon. Right? There's a saying in indie game circles that like making the game is the hard part. Working on the tech is the fun and easy part, the part that comes easily to many people. And then, or well, not necessarily indie game circles, but like, you know, do-it-yourself engine creation circles. Yeah, that happens. That happens, absolutely. Okay, let's see if we can make this actually build so that we can actually load this mod. This thing is called Jai mod, but it doesn't really do anything, right? So we have some code here that I've ported over. We have a basis. What is this called? This is called a module, I think. Yes, it's called a module. And here's the main file for the basis module. So we have some bindings, library API for the mod stuff specifically. Then we have some generated types. And this is how I get to almost immediately work with my engine. And this is what I mentioned when I said that like I made it pretty easy to actually hook into different languages, because I generate the bindings, and generating Jai bindings is just as easy as generating any other bindings. So I have something called SirBindAlot, which is my binding generator, and it generates Zig, Odin, C3, Jai as of a few days ago, and Rust. Although the Rust bindings are probably broken because I haven't really used that in a few years. But what you can see here is that it's generated 3 files for us. First we have the bind types. So for example, if you want to allocate from the heap through the allocator, the game engine provides for us. We have a function pointer, which we kind of like forward declare here under or type alias under a nicer name. And it's a function that takes a length and an alignment and then returns a UA pointer. Makes sense, right? We also have a print on host, which takes something called an interrupt string. So you can print basically like in this debug window here. What prompted the C3 addition? Just looked cool. Looked cool. I don't know what to tell you, man. I was just like, hey, this is nice. I'm gonna try it. I mean, there's no plan behind this. Well, there's a little bit of a plan, which we may get to eventually. But yeah, I wanted to try out various modern system programming languages. Anyway, yes, so we do a whole bunch of this stuff. You can see that we have like almost 1,000 of these function pointer aliases here. Everything from like AngelScript utilities to like here's IMGUI, here's some editor stuff, state machine, screen phrase, streaming utils, nav mesh, runtime. And this is like the core engine bindings that Zig uses. Zig has their own versions of this. So we go here and we go to generated types. Here we have the same thing for Zig. You can see that it looks almost exactly the same. You just turn some like C style pointers like this into just normal pointers for Jai. You have the same thing. Anyway, we have type aliases. Then we have some function pointers. So we actually store as global data like an instance of this function pointer. Heap allocation, for example, right here, or print on host. And we do that for everything as well, so we should have about 900 of those as well. And then finally we have binding functions. So you can see bind core, bind app, bind mod controller. And what we actually get from the core engine is an instance of all of these function pointers, and then we just store them here. Bloop. So what that means is that once we've actually done this, you can just call, print on host through this function pointer here, core print on host. And if we look at what we actually do here in the main Jai module file, I created a print function here for myself, which just takes a variable number of arguments. We do a temporary print or a print formatting print operation here using the temporary allocator. Then we create an interrupt string from that, which is kind of like a a manual slice. I think Jai calls them views. And then we just call that function pointer that we just set. And that's it. That's what we need to do to print from Jai in my game engine. And so if we actually look here in Zig, we have something similar. I'm sure we can find an instance of basis.print somewhere. Here we go. That's a commented out one, whatever. Let's just go to it. Print on host. You can see that we do basically the same thing. Yeah, I'm just actually, I have a fixed length buffer here, 256 bytes apparently. But I do the interrupt string and then I call that same function pointer. So simple. And because of this, I have like immediately, after messing around with Jai for 3 or 4 days, I can already do like navmesh queries from it without really having to do anything. Typically what I do is I don't use these function pointer thingies directly. I wrap them up in a nicer API so that you could use, you know, native Jai strings and things like that. But you can definitely do this. Just call these guys directly, because that is what we're going to be doing anyway under the hood. And to test this out, what I actually did, and I showed this off on the Jai Discord, is I drew a triangle. So let's see if we can actually make this happen here. That wasn't on this machine. That was on a separate machine. So I haven't actually built it here, but that shouldn't really matter. So what we have here is something called a mod controller. You can see that these procedures here are marked program export. So these are exported from the DLL and they are called by the core engine runtime at appropriate places. So here it passes as something called a mod controller interface int pointer. So an integer pointer. Because if you create a mod controller in Zig or in Jai or Odin or whatever, C++ doesn't know what to do with that. So it just holds on to it as a number. That pointer is just like a raw int pointer, right? And then when it's time to actually do something with that, it just passes it back. And so you can see here, this is what I've done in Zig, is that I'm casting it back to a mod controller interface, and then we can actually call things on it. So I'm kind of abusing this system here by pretending that I have a mod controller interface. I'm not doing anything with this pointer here because we really haven't created anything. But I'm just drawing a triangle and drawing a debug draw string. For this thing to be created though, we need to kind of fool the game engine to think that we have a mod controller. So I just have this call here, where we just pass the bogus pointer like this, 1, 2, 3, 4, 5, 6. And since the core engine won't actually do anything with those pointers, it would just go, okay, this is an int pointer to a mod controller. You can just pass anything there, as long as you don't try to dereference it. So I can just do this. Mod controller, create mod controller. This is also one of those function pointers that we just looked at. And through that, we should actually have this hard-coded, I should say, triangle floating in mid-air. So this builds, we have a DLL, but that DLL needs to go in the mods folder. So let's make a mod out of this. I'm gonna copy this mod JSON file from the Odin mod. And I'm gonna create a Jai mod folder here. Paste it in there, and we just call this Jai mod instead. Jai test mod, right? You just need to have some metadata about your mods here, so that the game actually knows what it is you're loading. Let's see if we can actually make it build directly into this folder. I think that should be possible to do. So I have a build.jai file. An output path is set to bin here. Can we actually make this output path is... Can that be just a an absolute path. I think it should be able to do that. So we're building into the app data roaming. Trampoline is the name of the launcher. This will, in launched or released games, this will be called Traction Point, this folder here. Then we have a mods folder and then the folder for the actual mod itself. So let's see if we can actually do that. Does it go in? Yeah, here we go. Here's our DLL. So now we can build directly into the game folder here. So let's see if the game actually runs. Maybe I can run it from this Visual Studio here. So what I typically do is I develop the game engine, so the C++ parts in Visual Studio, and then I write the game code, so the Zig parts in Visual Studio Code, if you're wondering why I'm using both. And then I'm debugging in whatever works best at that time. So we don't have anything on the screen yet, but if we go here to mods, you can see here JaiMod. It has found it. We need to enable it, and then it wants us to restart to load the mod. Because mods are only ever loaded when we actually start the game. So here we go. There's a cool triangle or triangle. A single-sided thing. How cool is that? But we are now actually running Jai code already inside of the game. So you can see it's loaded. If we go have a look at what the mod is, it's a Jai test mod. Its library type is native, so it's unsandboxed. So the reason you would want to run this as WASM, as WebAssembly, is that you want the mods to be safe to run for anyone. But you can allow unsandboxed native mods here, true, and that's that. So here's a beautiful triangle, which means that the mod is now running, and now we can actually make. Now we can put some effort into actually making it so that we can create components as part of the mod, and then attach those components to anything. There's really no limit on what we can do. You can even take this Scout game object here. So this, as we already looked at, this is called vehicles/Scout. You can even make a new object type, which is, based on this guy, and then add a bunch of Jai components to it, and then you can run it. That will, however, require us to add data to the mod, and I think that's a little involved right now. So what we're gonna do is we're just gonna hack the main game and add some Jai components to some of the object types that we have in the main game. Yeah, triangle, yes. Yeah, I needed to come up. I needed to be funny. Somehow. Anyway, that's it for the triangle. Let's get rid of that stuff now. We're not gonna actually create a mod controller here. We don't need a mod controller to have a mod register object types. A mod controller is kind of like if you want to hook into the main game loop of the game and do things while you are in the main menus, or run things during the startup of the game itself, then you need a mod controller, which is created when the game launches and then kept alive as long as the game is running. We're not going to do that here. We're going to create game object components, so we only run logic during the actual, when you are in the game, as opposed to like in the main menu, that sort of thing. All right, that would be that. So what I was thinking we would actually do here is we would take the Odin code, the Odin mod, and kind of look at that, because and you may call me out if I'm wrong here, but it kind of seems to me that at least syntax wise, Odin and Jai are kind of similar. So Right, it's here actually. We're not going to copy paste anything. Don't worry about that. If you think that's what I'm going to do, I'm just going to look at it, at what we actually have here. So in Odin we have something called, like for example, Jai and Odin. Neither of them have methods, right? They have just procedures, as opposed to like Zig or C3, which actually have methods. So if you create a mod in Zig, you can just have normal methods. So here we have like a, what do we have, like a, I want to find something semi-small here. Well, let's look at anything. We have a path fence component. This is the component that allows us to do just like draw fences on the terrain, or draw paths on the terrain. And you can see that this thing actually has proper methods that go here inside of the thing. They're just called destroy, like this. While in Odin we don't have that. We have a test component here. I think this is probably what we should aim to get, at least as a first thing. We have a test component that is a struct. It just has some data. The minimum component needs in this engine is a C++ context pointer, which is of type basis interrupt typed pointer. Interrupt type pointer is a small struct that contains an int pointer 64 and a type which is U32. You don't really need to care about what this is, right? It's essentially like a completely opaque type from the Odin's perspective, or Jai's perspective. You need to have it though, because that is how the game engine kind of identifies the component itself. Jai have methods, but it just namespace encapsulation that I'm aware of. Yeah, like yes, if you mean you can put procedures inside of structs, yes, you can have methods, right? But maybe that's actually something we want to try. Now that you mention it, let me know if this is what you mean here. So here we have, for example, test component create, and you could do this in Jai. You can do this in Odin, but we can do here. We could have a create like this, right? And then you give it a self pointer. Yeah, maybe that's actually something we wanna look at. That could be kind of a nice way of doing that. I know Jai is not really an object-oriented language, and you kind of shouldn't really make it do object-oriented things. Neither is Odin or Zig or C3. Well, C3 is kind of object-oriented, but Zig and Odin are also not object-oriented languages, and I kind of force them kicking and screaming to be a little bit, because the API that they're sitting on top of, the C++ API, is object-oriented. So yeah, maybe we want to actually do that. But regardless, here's kind of the API that I want to go for today. So we have a component, which is called test component, which is right here. And maybe we'll put these functions inside of it. As Desenk mentioned. You need to manually pass the first parameter this, yes. Yeah, that's fine. I mean, you need to do that in Zig as well. So if we go to Zig here, you can see we have a self pointer here to all of these guys. Blip, blip, blip. So that's completely fine. In fact, I kind of like that. Like there's too much magic in C++, right? And so I have a function here, or a procedure. I'm going to call them functions, I'm sure, all night. But a procedure called test component register. And if we go to the main file here in the mod, there's an init library thing which gives us a component registration callback. And if you have a bunch of components, you need to call this component registration callback for all of them. Here we're just registering this test component through this test component register function. Then when we deinitialize the library, we deinitialize the component types, right? Now what this does is that it goes through and creates a function list this is something I'm gonna want to try to not have in Jai if I can avoid it, and I think I can do it through the code generation, compile time code generation, or like, what is it, like polymorphic functions or structs or whatever. I can't remember the term actually here. But what we do here, and what I had to resort to in Odin, and I'm sure that this is actually not an issue with Odin, just me being bad at the language, I had to actually resort here to function pointers. So if you have an update, it actually goes through a function pointer. So this is essentially a virtual function call. This is annoying. I want to get rid of this. And I had some, yeah, here you can see some stuff here that I tried to actually make happen. And for one reason or another, this didn't work. But I'm gonna try to do it today for Jai, because I think it should work just fine actually. And it probably will work in Odin, I just haven't gotten around to it. So we're gonna pass the procedures here as parapoly parameters in Odin, and we could do the same thing in Jai, I'm sure. But here we just pass a function list, so it's a function pointer list to all of these components that you actually want to have, right? That's kind of what I'm thinking. And then, yeah, here in these test component thingies, we just print some stuff. We set the field to 1, 2, 3, and then we print it here. So we have a little bit of a lifetime kind of described here in these components. When the component is created, we call create on it, and when it's destroyed, its destroy function is called. This is like the convention of the game engine. And then when all of the components of the object have been created, on object created is called. So you have exactly the same methods in C++ and SIG. And so this is, if you want to get like a pointer to another component that lives on the same object, this is where you would want to do that, because at that point all of the components are created. And then, as we already discussed previously, we have update, pre-tick, and tick that we can do certain things with. So, you know, we want to do something like this. And we want to do it so that we can just create a Jai file. We can set up these things. So we set up the actual component itself. We set up a registration function for that component, and then some functions, which in Jai we might want to just stick here in the struct. And the only other thing that we want to actually do is in the init library procedure function, we want to call this test component register. And all that, how should I say that? That is all that should be needed to then add that component here on the data side. That's what we're going to want to do today. And then if we get that running, then we can do some fun things with that component. Make sure it actually like does something at runtime, right? And for that to happen, we're going to have to implement a component factory, which sounds kind of horrible and Java-like, but it's actually kind of not. It's not that bad. I'll show you in a bit. I'm going to have to implement this components file as well. It has some flags, and it has this init component type thing that we call when we want to register a component, and then deinit them. And then there's some bookkeeping stuff. All of that, right? So let's get started. I'm gonna go get a glass of water, and then we're gonna get going, because I've just been yapping so much. So, 1 second. Alrighty then, water acquired. Yeah, I wanna emphasize here still, if we have any Jai experts in the chat, or even just like anyone more experienced with Jai than me, feel free to shout out if I'm doing something stupid. I'm sure I will be. Okay. So, I'm just looking at my notes here, because I actually did write some notes to make this kind of smoother on myself. Like normally I wouldn't really trust myself to be able to do this sort of thing on stream, but I've done it twice now for other languages, so I bet I will be able to do it here. Okay, so we're gonna start by creating probably the component factory. And I will explain a little bit about why we need something like that and what it is. And so the problem is we are communicating across language boundaries here. Of course the core engine has no idea what a Jai is. It only knows that we have a C API, which we have here in the library API. So here we have an API for the component factory. And so the idea here is that every component type that we register in the mod, it gets its own factory created for itself. That is why when we actually init the library here, we have a callback, component registration callback. We can have a look at what that actually looks like. Where is that? Is it here? Yes, here it is. Component registration callback. So for each type that we actually want to hook into the game engine, we need to give it this weird looking siglib C++ pointer. This should kind of actually be called like, you know, jylib here, but whatever. Just assumes that it's a sig library and not a Jai library. We give it the type name, and so the type name is what we will actually be able to in data use to refer to this component type, and then a hash for that. Context type name is something that I'll get to in a little bit. It's just a string, doesn't matter. We give it an update sorting key, so something between I think it is 0 to 255. So if you need to sort, if you have like an animation component that you want to be updated after, like a logic component or something like that, you can sort them. And by default it's set to 50. And that's that. Then you have a factory interface pointer. It's again one of these int pointer thingies. If we have a look at what an int pointer is, it's just a type alias that I've set here. You might be wondering why do we have an int pointer and int pointer 64 when they're both actually 64-bit. If we're building a mod to WASM, currently I support only WASM 32. So I need to be very specific about, okay, this is a 64-bit pointer, this is a 32-bit pointer, blah blah blah. In DLL mode, which is what we're going to be, you know, native mods, which is what we're going to be building this thing as, they're always U64, so I just hard-codedly put it here to U64. And then a CPP pointer is also U64, so this is just to sort of document that, okay, this is a pointer to something in C++ memory. Just like C++ can't actually reason about anything that's created in Jai, we can only hold on to its int pointer. Jai can't really reason about anything that's created in the CPP, so it can only hold on to the CPP pointer, and the CPP pointers are always U64. And then a WASM function pointer, which is U32, but yeah, we're not using that. It just kind of comes with the API. Anyway, when we're registering this component thingy, we need to pass it, hey, this is the factory interface pointer for this component, so that C++ knows that, hey, at the end of this strange looking int pointer here, which is completely opaque, is a component factory. And a component factory is something that we can tell, we can tell the Jai code, we want a new instance of this component that you claim to be able to create. And so we have a function here for that. C factory, component factory, new component. And here we get back that interface pointer. So this factory, we don't get the type here. Instead, we get the factory, because the factory and the type are like, they have a one-to-one relationship. We get the CPP context pointer thingy, which we already talked about when we looked at the Odin thing. That's the thing that you're going to be storing inside of the component itself. So basically like, let's have a quick look here. In the test component, it was this guy here, which, yeah, according to this component or this comment here, we want to wrap in some nicer type. But yeah, the component needs to hold on to this thing because it's like its identity on the C++ side. So we get that passed to us here. We want to create a new component. With this factory, we get the context and whether or not we're on the client or the server. And then we cast this interface int pointer here to a component factory interface, and we use that interface to create a new component. And then again we get an int pointer, which we then pass back to C++, right? Yeah, I have some fix-up things here that when I did the initial Jai work, I marked up some places here. We're gonna have to actually implement all of these fix-up marked things to have like basic components working from Jai. That's how it works. That's why we have this factory thingy here. Also, when we update components, so here we have an update components exported procedure. It also gives us the factory interface pointer. So that basically tells us that, okay, we're not updating individual components. If you have a single component type, but we have 2,000 of those components, we get a single call through this method, or this procedure, I should say, from C++ to this factory. And then inside that factory, we can update all those 2,000 component instances, right? So rather than having 2,000 virtual function calls, we just have one. And then the factory itself can update them in a very tight loop. That's kind of the point here. And because these are all just exported C functions, C call, each factory, even though we want to make it so that the factories are kind of like generated for us, and they know at compile time the component type, they need to have a common interface. Right? So basically, here if we go and have a look at the Odin factory, we can see we have a component factory interface struct. Methods for the actual component factory and methods forwarded to individual components. Right? So we have a function here to deinitialize a factory, create a new component, delete a component, and then do update, pre-tick, and tick. And actually we have like probably 20 more in the full version, but these are the ones that we need to be able to manage components. And so again, if you call like an update here, this is an update call to all individual, perhaps 2,000 instances of a component type. And then we have some calls here that are actually forwarded to individual components. Create on object created and draw editor. That sort of stuff. So let's actually just yeah, I think we're actually going to copy paste this. I kind of fooled you a little bit previously when I said we weren't going to copy paste anything, but I think it actually makes sense to copy paste this. So let's create a file for ourselves here in the basis module. Call this component factory.jai. So finally we're actually writing some code here. Now, I need to do some find and replace stuff here to convert this to SIG syntax, right? Something like that, and I think these should all end with a semicolon and not a comma. So the syntax is kind of similar, but it has its differences, right? And then these are called, is it float 32? Something like that. Is there something more? I think that's probably it. That looks like Jai to me. Oh, that's not Jai. There we go. Now it is Jai. So this is the interface that all of the factories need to implement, and we're not going to be creating those by hand. They're going to be generated for us when we register a component, right? So the way the factories work under the hood is completely invisible to the user. That's what I'm hoping to do here. Yeah. So here we have the actual factory. Maybe we can. Yeah, I bet we can copy paste this thing as well. So this procedure here is called make component factory interface. And I think actually, I don't think this will compile because that's called like type in Jai. And then these pointers here look different, right? Actually, let's come back to this later. I'm just gonna. What is that? It returns an int pointer, doesn't it? No, it actually returns a factory interface. Okay. Okay, so we need to do a little bit of work here to actually make this work, but I think we can keep the interface there in the beginning, and I'm just gonna comment these things out. Hey Jake, no, you didn't miss the Jai part. We're doing the Jai part. We're doing the Jai part right now, and we'll see where this takes us. So we're making a factory interface. We're passing it the type that we want to create, and then, or actually, we're passing it the type of component that we want this factory to create. Then we pass it the factory pointer, which is a component factory. We don't have that struct yet, but we can take it from, because it's right here underneath this procedure in Odin. So let's take it from there. Let's convert this guy as well. And so this would be called again type, right? There's the interface. We don't want the function list. I'm gonna get rid of it now. I'm gonna go on a limb here and say that I'm gonna fix that for the Jai version. Then the dynamic arrays they look like this in Jai, which is interesting, but okay. And then we want all of these to have semicolons as well. Right. So this should now all be valid Jai, I think. No, but this is actually probably not valid. At least we need a semicolon there. And I bet we don't actually need that. That's like a quirk that Odin had. And I think the cast looks a bit different in Jai as well. Cast is like this, isn't it? Right, that would be Jai. Actually, it's not. We need a period here, or a dot. So if I'm understanding this correctly, you can do like component factory interface like this, and then you can use the dot squiggly bracket to initialize it, or you can have it here. I think this is probably the nicer version here in this case. Yeah, let's try that. And then we need to. probably load this file here. don't we? So let's do load component factory joy. And let's see if this builds. It does not build. Oh, semicolon. Yeah, I bet we're gonna get a lot of that because we're converting from Odin here. So semicolon, and I can't do that. I can do this. Yeah, okay, that builds. So you know, obviously we're gonna have to convert this as well. But anyway, we have an interface thingy here now. Now the thing I want to make different here from what we had in Odin is that we don't want this function list everywhere. So in Odin, and I want to get rid of this in the Odin version as well at some point. In Odin we have this function list, which is a list of function pointers. And you can see that almost all of these things have like a function factory pointer dot function list dot, you know, function. If that is not nil, then we go in and actually loop over these things and call update. And here we have pointers to t. In Jai we have pointers to t. So maybe these should actually eventually be, you know, like this. So we have an array of components like this. The thing is though that the component pointers need to be stable in this game engine. So I'm gonna have to create my own container for these that like leaves holes when you delete something and then fills them in later and things like that. So that pointers remain stable when you add and remove stuff. Probably allocating like buckets or something. I don't know. That remains to be seen. So now we have the interface, and we have a way to create the interface, but we don't really know this stuff yet. So what I was thinking we might be able to do here, looking at the Jai how-tos, is what if we actually gave these components, or what if we gave this procedure here a list of the functions that we might actually want to run. That maybe sounds strange. Let me show you an example here. Where's create? Create. So create is right here, and create is a function that doesn't return anything. It just takes the component pointer to it, right? You can see it up here as well. We have the factory interface, yes, but the actual create function takes just the component int pointer. It doesn't return anything. So if we want to uncomment this thing, we need to convert these again to, let's like mass convert these things to Jai syntax here. So something like this maybe. Rip. Component factory interface, that should be fine. Something like that. So now we have interface.create is an anonymous function that takes the interface pointer and the component's integer pointer, int pointer, and it casts it into the factory pointer, which probably looks kind of like it does currently. I think it would be something like that, right? So these are pointers in Odin. If you're wondering what that is, maybe we can just mass convert those as well. Bloops, like so. And we're gonna have to remember to add those semicolons there. But of course we don't have this function list thing here. So what if we just pass as like a parapoly parameter, or whatever it's called, the thing with the dollar. Just pass a create function here. Create function, just like a self pointer t, right? Like this. And then here in the create, we quite simply call. So we don't need to check that thing, and we don't need to do any of that. We just need to call the create function here. So we're passing in the create function at compile time. We know at compile time what this thing is, and then we call it here. The problem here is that what if the component doesn't have a create function? And again, looking at the Jai examples, I think you can give a default parameter here, a default value to this parameter. But maybe we can look at that later. Does this compile first of all? Have I gotten the? Yeah, I have the syntax correct. It looks like. So what we are doing now here is, when you create this interface, give it a type, give it a factory pointer, which we create elsewhere in the Zig version as well, or in all the other versions essentially. And then we need to give it this create function pointer here. I think we're not gonna have any default values here. We're gonna have them on a higher level. Anyway, let's get back to that in a second. We have a few of these guys actually that look exactly the same. So we have like destroy function is exactly the same. We have on object created. It's exactly the same. We have draw editor, which is not exactly the same. It also has selected bool and hovered over bool. I hope this works now, and I hope this is actually like the correct syntax, but I think it is. So this would be update, and update has delta time, which is a float 32, and then we have two more, which is pre-tick function and tick function, right? And these, it's essentially the same, but it's like the fixed delta, so it's called tick delta time, not rather than just delta time, right? That should be like all of them, essentially. Create, destroy, on object created, draw editor, update, pre-tick, and tick. At least all of the ones that I have created for Odin and C3 and all of that. I'm not gonna do all of these other ones here. We're getting everything we want now, so then we can just go in and fix them up. But I wanna make sure that we can actually like run something pretty soon, right? Now that we have this though, where do we actually create this component factory interface? If we go back to the Odin version, we also have a make component factory interface procedure here, and we create it here in init component type. And init component type is what is called here from the function that actually like registers a component. We tell it, okay, the type that we want to register is test component. We give it its name that we can refer to it in data. We give it game object component, which is the so-called context, not to be confused with the Jai context or the Odin context. We don't really have to worry about this for now. It's always going to be game object component. We give it the function list, which we actually don't want to do here in Jai, and then we give it the default update order, and then we give it the callback, which is passed here. Hey, Xluxy, welcome back. And so this init component type thing is the thing that actually calls this make component factory interface. And here you can see my failed attempt, and we're gonna attempt this now. Right here and now. So what my plan was here, which failed, and I think I've almost got it. probably need to consult some Odin people for how to do this. But I wanted to pass the create, destroy, on object created, all of these same things that we just listed there. I wanted to pass them here as like compile time known functions. And if something doesn't have, you know, say an update procedure here, you would just pass this nil update to it instead. And so we're going to do exactly this. We're going to add this procedure here. I'm going to do all of this stuff. And this will actually go in and create it on the C++ side then. I think we're going to copy basically all of this. Just going to do a little bit of engineering here in Jai. So let's create components.jai and copy or paste rather this thing here. Just immediately comment out most of this stuff. All of that. Right, we don't have a proc word in Jai. We don't want this component list at all. Go away. Bye bye. Bye bye. And then oh yeah, I want to try this. There's something called enum flags in Jai, which should be actually perfect for this kind of flag enum. And then we want these to be semicolons. So here, for example, you can see that, okay, it has values here for has update, has pre-tick, has tick. Also has a bunch of other things that we're not really gonna get to today, but eventually we're gonna want to support all of that stuff in Jai. Right, let's just get rid of those guys. Bye bye. And then come to this thing here. Again, this is called type. Component type name is a string. Component context type name is a string. A function list we don't have, so we can just get rid of that. Update sorting key is a U32, and the callback is that. That should all be good. And then we have a separate one for deinitializing stuff, which we can actually call here. I have the call here already. I just have to comment it out. But that's basically that. So can we build this now? Let's see. Okay, we cannot. What's going on? It's not a member of import basis. Ah, okay, I need to load the thing, right? To load the thing here. Does the order here actually matter? Does the order here matter? Maybe I'll put it before the factory one. Can any Jai experts in the chat tell me, does the order actually matter of those loads, or is it just that you need to actually load them? Oh, we're missing a semicolon again. That's fine. Loose data assignments not currently supported. Oh, that needs to be like one of those, right? That's how it, yeah, that's how enums work in Jai. No, order doesn't matter. Okay, cool. Thanks for the clarification. Cannot call into native procedure from a. Oh, right. I need this thing here, right? Yeah. So Jai also has this concept of a context. I actually do it already here, and a context is kind of like it's something that's found in Odin as well. And context is something that has like a bunch of handy things like allocators and that kind of stuff. And the Jai calling convention kind of requires a context unless you specifically mark a function as not having a context. This is a C, using the C calling convention. So this guy doesn't have a context. That's why we need to push a context here when we call into a normal Jai function or something like that. That's how I understand it. Yeah, we're not gonna be overriding any of the allocators or anything like that, even though the engine has support for that. Just gonna leave them as they are for now. Cool. And I bet we actually probably need to, while we're at it, probably need to like move that there. I can take that print away. Probably need to move that there as well, so we have a context. Let's see. Instead of replacing commas with semicolons one by one, you can select the topmost one and then use the add selection to next find match. Control D for me in VS Code. Oh, let's try it out. Let's replace something here. So if we go to components and we replace that, Control D, and then add like 7. Oh, you can. Okay, you can do it. Yeah, okay. Yeah, you need to like. So basically, okay, if I have this, right, I can do that and then do Control D a whole bunch of times, and then press that. Hey, that's pretty cool. Thanks for the tip. I'm learning all kinds of things today. That'll be useful for lots of things. Cool. Okay. Then we have these guys, and we basically want to copy those things that we created here in this factory, right? So if we take these guys from here, and yeah, I think I wanna leave a space there in between these things. Now, what I want to immediately do here is add those null versions of them, so that we can have default values that you know they can use if you don't have any of those, right? Let's maybe we can create them here and then move them somewhere else. What do we do, like comp create or whatever? And that's a procedure, and we just give it. Is it that? And then maybe we can do basis dot print null comp create called, right? Something like that. And then we assign that to that. Does that work? Expected an identifier after $. Does it need to go the other way, maybe? Is that how it needs to be? Okay, there we go. So null comp create. We're just going to print if we call these, like, if we fall back to the null versions, right? So we have a destroy one as well. We have a null comp. What's it called? Let's create a few of these guys. Oh, null. What? We have a few of these guys. So we have on object created. And then we have and it needs to be the other way around. Null comp draw editor. And this had the two other, so it has selected. we're doing like doing level editor business here all of a sudden, but this will be useful. I'll show you in a bit, hopefully. Null comp update, null comp pre-tick, and null comp tick, right? So if a component doesn't have an update, we're going to be passing this one instead, and then we're essentially not going to be calling it. So we're not gonna. First of all, we're not gonna have these prints here. They're just to make sure that we actually get what we expect, and we're essentially not going to be calling this. But I think I need to give it something anyway. right? I don't think you can call nothing in Jai. Or if you can, let me know in the chat, and then we'll try to figure that out as well. But yeah, by default, these will just be this, because Jai allows you to pass parameters by name, which should be a pretty nice way to actually register this, right? If you only have, let's say, like a create function, then you need to give it all of this stuff that you need to give for every component, and then you can go, oh yeah, and it has a create function, and it's this or that. That should be pretty nice. What? 2 arguments versus 1 argument. All right. Yeah. Absolutely. It's basically that. There we go. So now we have essentially the interface for how we're going to register these components. We call init component type, and we pass it some stuff. So maybe now we should actually create that component. Let's create test component here. Component.jai. And here we're simply just going to be doing test component is struct like this, and we are going to want to have, let's see, what was it? What did it look like? Let's just copy that verbatim over. Except I think this needs to be. Yeah, this is confusing to me. In both in Odin and in Zig, signed integers are called I, but they're called S in Jai. So I make that mistake all the time, but that's an S. Is there a reason why you call it null and in Odin you call it nil? I don't know the semantic meaning of nil, just by experience. Nil is a stub and null is 0. Odin calls it nil. That's why. Let's see if we can find. Yeah, look at this. Like nil is the actual. Nil is the actual keyword in Odin. While as far as I know, it's null in Jai, and null is, you know, what I'm used to anyway, because it is null in Zig and it's null in C++, or it's null PTR, but whatever. Null in C# and so on, so I'm kind of used to calling it null everywhere. But yeah, it's called nil in Odin and in like Objective-C, maybe some other places. So that's why. Let's try to make these things actual, like functions inside of the struct now. I haven't tested this out, but this could be kind of interesting. So let's call this register. And it takes a callback, which is the it's the basis component registration. What is it called? With a large C or capital C. Component reg callback. There we go. That one. And then this would be basis dot init component type. And first of all, we give it the type, which is test component. I guess we could give it like, what's it, like self or something here? I don't exactly know. And we need to give this a name that we can use. And this name is important that we remember it, because it is what we will be using here when we actually refer to this component. I'm gonna shut down that preview there. Also in Go it's nil. Oh yeah. Though null is by far more common in most languages. Yeah, isn't nil like a, isn't that like a British thing? Or have I gotten that wrong? So I'm gonna call it jai.test component just to, you know, use something that we for sure don't use in the game already. And then the context is going to be game object component. It has to do with what kind of component you're creating in the game engine. In C++, which is you can make a a game in just 100% C++ in this game engine. That's supported. You don't need to use SIG or any other language. And in that case, this is essentially the base class, what you're deriving your component from. But we don't have base classes in any of these other languages, so yeah, you just give it a so-called context out of a few supported ones. Game object component is the basic one, base one, whatever. Let's go to init component type and let's see here. Actually, I have the technology. I can drag it over here, and we can see, so we have the type, we have the component type name, component context type name, then the update sorting key. This would be basis dot, and it's basically this thing, component default update order. It's 50. And then we give the callback. And now, this is the interesting part, to me at least. Can we do this? Can we do create? And that's how it looks actually. And we do self, and then we give it a test component. And we can do like basis print. Let's just do test component create, like this. Called whatever. So rather than having oh, it's not there, it's here. Rather than having null comp create called, if we actually give it a create function here, create. Can we do that? Would that work? That would be nice. I'm gonna move these down here below this stuff. Let's get one of these. I have a snippet for adding these separators in Zig, but I don't have it here in Jai. Right, then we probably need to actually call this, or maybe we don't, but I'm gonna do it anyway. So how do I actually do? I just, yeah, I need to load that thing in here, right? Load test component Jai, and then I can do test component dot register and pass it the callback. We can get rid of this guy. Will that work? At least it builds, so that's nice. Yeah, that's cool. With name parameters, order of parameters doesn't matter. Yeah, it matters up to this point though, right? Doesn't it? Not. Like if I start by just passing these things, it matters up to this point, and then after this, that's why I leave like an empty space here. This is how I kind of imagined I would do it in Odin. That's why I'm thinking of doing it here as well. Anyway, let's do it like let's do a very basic version here first. So let's do a destroy function, so we can sort of get the whole lifetime of this component. So let's do destroy. That would be destroy, and then maybe an update. Well, let's do a tick. So tick, tick, and then this would be tick delta time. That's a float 32, not an F32 as I'm used to. That would be tick called. That would be destroy called, and then I think we can do tick delta time is %. And we're gonna actually want to have new lines after this, because otherwise we're gonna be messing up our stuff. Let's do tick delta time, like that. And while we're at it, let's do some field as well. Some field. We can use the self pointer here. Self some field. I'm not sure, but I use it always and never got a problem with it. Okay. Likely the same rules as any other language. If they're ordered args, they must be the first ones, and then you can go by name after that. Yeah, that's what I assumed as well. That's what I assumed as well. Okay, let's see if this builds. It does. Nice. I just love this fast build. But to be fair, like with as little code as this is, Zig would also build very fast. But Jai seems to come up on top of the build speed competition there, for sure. Okay, and then we need to do this. Tick fn is tick. Okay, so here we have our little component. Maybe we'll want to do something here like self dot some field is, I don't know, 343 industries, just to make sure that we actually, you know, there's a little bit of communication between those functions there. Right. Cool. So what do we do then? Then we have basically this. We need to fill in these functions here to make it work. I know we're doing kind of quite a lot of stuff, like sort of like front loading a lot of work here. Unfortunately, I don't think there's really any way around that. We're gonna have to do a little bit of stuff here to make this work. Hopefully this is not. Hopefully the payoff will be worth it in the end. So just uncomment these one by one and make sure we can actually figure it out. So interface dinit. This is deinitializing the entire factory, right? The factories will be created on the heap. At least that's my initial plan. I don't think we need this uint pointer because I didn't need it in some other places yesterday when I did the previous work. So deinitializing the entire factory. Yeah, we actually need to implement this function. All right. I think that function we can take from the Odin one. Yeah, so we have the factory itself, which we already have in Jai, don't we? Yes, we have the factory here, but then we need the init function, the new component, and the delete component. We're gonna have to fix up all of this stuff. So there's a type ID thingy, and there's a pointer thingy, and there's a proc thingy. Let's get rid of those procs. Type. I'm just fixing up some of this stuff by hand. There's not that much to do. Let's comment that out because I'm sure we're gonna have to do a little bit of this. I have some commented out stuff here. This is actually Zig code. BP props stands for blueprint properties, which is essentially these things. So if you have a component that has some like properties that you can set here in the blueprints, we basically get rid of them here. I've just left it there. Factory is one of these guys. There's a client components and a server components dynamic array. You can try pressing create function as a first parameter and test. I think Jai has different rules than other languages. Okay, we can test that a bit later, for sure. See how that works. I'm gonna get to some fun stuff. Yeah, free. So Odin has both delete and free. I think the Odin naming convention for those are kind of strange, but I think we're supposed to be calling free, and we're supposed to be calling free on the data. At least according to my how-to, which I have open here on another monitor. So we're freeing specifically the data that the dynamic array has allocated. Isn't that how it works? Unable to parse type instantiation. What? Oh. Yeah, let's replace those with those. There we go. Right, so that works. So now we have this thing. We have some commented out stuff here that I will leave. We could go to new component. And here we want to... don't think we need to do that. We need to do something like this, and that's supposed to be new with a large N, right? Isn't that how it works? Yep, that's it. And then basically we need to dereference that thing. I think in Java it's that, isn't it? And then we do D or T dot, and we pass it the CPP context pointer is CPP context pointer. Yep, that seems to work. So now we can do this thing. Like so. Yep. New component. Get rid of that. Yep. And then, right, so if we are on the client and server can run on different threads. Actually, they do by default. So we have different lists for them. Array add is what it's called in Jai, isn't it? And this is strange. Like they use, that's the address of, isn't it? I don't know why they just didn't use the ampersand thingy. And that's not how cast works in Jai. It looks like this. Cast. Yep. Oh, that's actually, yeah. Isn't it like this? It's using the same syntax as Sig does, actually. Both of them compile. Maybe it's the fact that I'm not using it. It's like a polymorphic function or whatever it's called in Zig. I don't remember. But yeah, I think this is how you dereference a pointer, right? I think I saw this somewhere. Yeah, why did that compiled? Yeah, so this compiled, but that's actually taking, like, this is just shout at me if I'm doing this wrong. That's how you get the address of something, and this is how you dereference, like go the other way, if I remember correctly. Because I was reading the how to and I was like, oh, they're using the same syntax as Sig actually, but this this compiles somehow. I'm gonna go with that though. I think that's the correct one, because it also compiles, and I think that is how you're supposed to do it. So we'll see what happens. Okay, now component pointer. Yes, Odin required me to do this weird sort of double casts here. All right, so we have a destroy function. We don't actually. Yeah, we need to pass that there, don't we? Like we need to pass it to delete component. This guy. So let's just take this guy. I'm gonna make it. I'll put those guys there at the front, right? That's not supposed to be a self. That's supposed to be a. What is that? That is component PTR. Component PTR, and then here we can pass destroy FN to it. That should be fine, and then here we can just quite simply just call it destroy FN with the component pointer. Something like that, right? Right, how do we remove things from an array? Removing things, okay. Unordered remove by value, unordered remove by index. Oh, cool. Ordered remove by value, let's use that. I'm using an unordered remove here, yeah, I know, but I think I actually do an ordered remove in Zig, so let's use that component pointer. Oh, nice that they have a function for that already baked in, so we can just take that, then we can plonk it there, server components, and then we do free. So okay, let's see what we actually do here now. I'm just kind of mechanically almost, you know, doing this thing. If we are deinitializing the entire factory, we are freeing all of the components. Or rather, we're freeing the data that these component lists have allocated. And then we're freeing the factory itself. If we're creating a new component, we allocate memory for it. We set the... well, the context pointer really here, but we could set more if we wanted to. And then we add them to these lists. And then we return the component pointer as an int pointer 64. We're not calling create here, by the way. That comes later. If we're deleting, we do call destroy on it, and then we are removing from those, and then we're freeing the component pointer. That looks good. Right, I'm missing something, aren't I? Yeah, I'm missing these semicolons from there. What's the ordered versus unordered remove? Is it just leaving a hole in the array and copying everything over? Or how about it searches for the value? I would assume it does, yeah, it does like a swap, right? So ordered remove by index. Yeah, you can see it's copying everything. It's not leaving a hole. It's just copying everything over and filling that hole. And I assume the unordered one is just swapping it with something else. Is it not? Yeah, there we go. I don't understand this though. What is happening here? Unordered remove by value. Removed plus 1. Remove. Wow, that's a keyword. What does remove do? I haven't seen that before. Anyway, I'm pretty sure that's what happens. So let's just accept it and move on. All right. Let's see then. So we have new component, we have deinit, new component, and delete component. All of that is fine. Then we have update. And this should now be a bit simpler again, because we don't have this function list business happening here. Yeah, we should just be able to like not have that if statement there. And here we would quite simply just have update fn semicolon, please. Same thing here. But the for loop doesn't look like that, right? That's not how we do a for loop. No, there's no in. I think it was pretty simple to do a for loop. You can just do for that. But then you need to somehow... Yeah, what is that? What's that gonna be named? Like in Zig you would do this, you would do PTR, you would capture the value that way. But that's not how you do it here. How do you do it here? This will just complain that, no? What? And that, I'm sure that's not how we do it. something funky here with like the compiler accepting stuff. Oh, right. It's, yeah, okay. It declares like an iterator for us, like that. Yeah. It is, you know, hello. My name is Santa Claus. Like, oh, it's written like that. Like the compiler just accepts that for me here for some reason. I don't know why. It probably has something to do with, I don't know what it has to do with. It's weird. By default, for pointer is IS. Is that how it? Okay. All right. Well, let's see what happens. Maybe this will just blow up in my face. I don't know. I'm a little confused by the fact that like I can do seemingly random things here. It's confusing, but actually I'm just gonna copy that thing and just move it here, and then we do pre-tick. Does that work? Now I have that. That is like the wrong name. Yeah, it does work. Why does it work? Why are you not complaining? That makes me a bit nervous. But yeah, I don't know. So tick is going to be almost the same as pre-tick. So I'm just going to do that. And then we're going to get rid of that and that. If I just type some random crap here, like it does pick up on them. So clearly it is being, you know, considered. Okay, let's keep going and see what happens. I don't know. I don't know what to tell you, man. On object created is going to be almost the same as that, so we can just get the function from here. And draw editor is going to be almost the same as that, except we have some. Yeah, let's just get all of that going, and then selected and hover goes there. Okay. Okay. This looks pretty good. Does it not? I think it does. You need to call the procedure to force type checking, maybe. Something like that, maybe, yeah. Yeah. Pragma export to force the compiler to type check the procedure. Oh, you have some. Have some issues sending. That's unfortunate. See, what I'm thinking is that this is a what do you call it? Is it like a parametric? Like Odin calls it polymorphic. No, parametric polymorphism. When you have parameters like this. And so basically this is like a template. You know, I'm a C++ guy, so I don't know what to call it, but this is like a template, right? And sometimes in C++, if you don't instantiate templates, you can just write some crap there. It kind of depends a little bit on the compiler. Maybe there's something slightly similar going on here. We are right. We're not calling it. That's why. I bet if we okay. Well, it's gonna be the thing that we do next anyway, so this is perfect. I bet if we actually call this thing, it's gonna break in all kinds of ways. So let's do this thing that I was confused about previously. is here. I'm gonna break this, right? And let's put a comment here. This probably breaks, so I can remember where it is. Like, I don't think that should work. That should not be good. But we can compile now. So let's go here, and we're actually gonna call this guy. So what we are going to do is actually make this. I don't like that. Let's get rid of that. That's supposed to be a large N, right? We create a factory. Yeah, we don't have the function list here. Maybe I'll just do like factory dot iFace. iFace is, and here we have this thing. This is probably going to break now. We're gonna be passing a whole bunch of things to this guy. We're gonna pass the type, and then we're gonna pass the factory pointer itself to it, and then we're gonna pass the create function and the destroy function. Well, we're gonna pass all of these guys. Yeah, pass all of these guys. Draw editor, update function. We have pre-tick function, and we have tick function. Right. So now if we build this, what happens? The polymorph was triggered here. Let's clear this so that we can get like a sense of where this starts. Okay, so first of all, we have one of these guys here. Yeah, we need to get rid of that. I ran into that issue yesterday when I was converting some of the Odin stuff to Jai. Ah, hair. Yes. Yeah, okay, so that was the issue, that I didn't call it. And that's why it broke. We have some other stuff. Oh, F32. Keep making that mistake as well, because it's F32 in all of the other languages. Undeclared identifier basis. Right, this needs to be just print rather than basis.print. Get rid of these. Yeah. More F32s. There's an F32. And there's an F32. Do we have any more of them? We have more of this crap, okay? Okay, yeah. Too many arguments. Oh, that's called Pro Editor FN, I think. There we go. All right, cool. Polymorphic compile time. No call to it, so it did not build a templated version of the type since it does not know it. Yes. Yeah, pretty much. Or rather, it didn't build like the actual. It had a templated version of it, but it did not actually instantiate that template anywhere. And so it makes sense that like type checking isn't done. I sent some messages too fast. Maybe my internet is losing packets. Okay. What's the $sign do? Looks to only E on lines with generic templated stuff. The $sign, as far as I know, specifies that we need to be able to tell this thing at compile time, and you can only have like a single $sign here for, like here, for example, we have this component factory dinit procedure. We make it sort of templated based on this T, and you can't have it more than once. So, you know, if you have a second type here, this won't work. Well, we're redeclaring T. Yes, I know, but still, you can't have it here either, because okay, it's the same error actually. But you need to have it only once, as far as I know, and whatever you pass in here kind of assigns it to the T. And then when you use it in the other places, it uses it rather than assigns it. Something like that. That, as far as I know, is how it works. Right, so the next thing we need to do is implement the rest of this function here. It's where it infers T's type from. Yeah, basically. Like Odin works the same way. So that's basically where I've gotten it. Right, so here we have this enum flags. This is not a normal enum, it's an enum flags. And based on the how-to that I read, we should be able to do something like this. So we have like component flags, which is not a U32 here, but it's actually like a component flags, like that. And then, oh, now we need to compare that thing. Ooh. Does this work? Will this work? Will this work? I wonder. Semicolon expected after expression. It's right there. All right, we need to. Yeah, okay. We need to do something like that. Yeah, that does seem to work. At least it builds. So let's assume it works. So pre-tick. Okay. We have those. We have those things there, and we're gonna do that, and then we can get rid of that again. And then, you know, we have tick. Oops, got rid of the if as well. I don't know how I feel about the fact that you don't need like braces around these, like that. Like, I think you can probably have it, but you're not really supposed to. If you're writing idiomatic jai, if there is such a thing, maybe there is. It kind of feels a little dirty to me to not have those braces around it, but maybe I'll get used to it. Okay. Write it then. Does that work? Does that build? We're approaching the end here of this boilerplate stuff. Should be able to actually create some stuff pretty soon, and then if all goes well, we'll be able to do all kinds of things all of a sudden. So there's component flags. That's fine. We're gonna pass them there. Right. So then we have this GCF pointers thingy. I'm not sure this is actually really the way I want to do it in the end, but both in Zig and Odin and C3. But how I've done this is actually I just have a global array here of things. So I have a component factory pointer storage. We have the actual pointer to the interface, and then we have the factory int pointer. We keep this around so that we can then, with this one call, we can get rid of all the factories when we shut down. And yeah, here's just a comment that says that, okay, we actually support 200 factories on the C++ side. So let's do the same here. It's a bit, yeah, I don't know. Maybe there could be a more elegant way to do that, but let's just do it here for now. It's fine. We can't make things private like that in Jai, but that's fine. So So here we have a pointer. That's a semicolon, semicolon, and that's a semicolon. And that's a semicolon. I don't think we need that initialization there, to be honest. Something like that. So we have a global component factory pointers, component factor pointer count. And maybe something like that. And semicolon as well. Undeclared identifier I. Oh right, it's IT iterator, isn't it? Yes. Cool. So factory int pointer. Again, we do a whole lot of different casts here, when really the only one we need to do is probably that. And that can be an, whatever that's called. Yeah, and here we're not using that ampersand there, unfortunately. I'd like it to be the ampersand. And here probably needs to be a period. What about that? Does that build? Semicolon. Oh, it needs to go after that one, does it? Yeah, but we also need one after that one. Okay, there we go. And that should be fine. That's just that's actually another global, another piece of global data. Yeah, I made this, I've used this underscore G here. Actually, maybe that's kind of nice. Just a signal that, hey, you're not supposed to mess with this. I don't know, can you make things private in this language? So that it doesn't show up in IntelliSense and all of that, but at least the underscore is sort of a signal that, hey, this is internal stuff, don't mess with it. Okay, so we have a few more lines here, and then we can actually call the callback here finally. To interop string. Interop string is something that I kind of mentioned briefly previously. So an interop string here in that's Odin. Where can we? Why can't you go there? I can find it here. Oh, there we go. Interop string. So it has a pointer and it has a length. It's basically a slice, just a manual slice. And we want to have an interop string function or procedure, so we can make strings into interop strings. And we also need a string hash, which is going to be the that's going to be actually interesting. We'll get back to that in a little bit, but I'm gonna actually, yeah, I'm gonna make a string utils jai file here. String utils jai. I'm then just gonna have a toInterop string. I'm gonna give it a string, and it returns an interop string, like that. And let's give it a no context directive, because it's really only going to be kind of packaging this thing together. So we're going to have interop string. Why can't we actually see that now? That's kind of weird. Is it maybe because I am not loading it into the module? That maybe be why. Load string utils. No, I can't see that interop string here. And that's kind of annoying, but let's try to okay, now we can see it. Okay. Apparently it was because of that. Yeah, now we can see everything. So this is string data, and this is string, is it count? Probably. But count is an S64, so we're gonna have to cast that to U32. And that's it. And maybe I actually like it to be spaced that way. So that would be that, and now we can do type name, and we can do context type name. Right? Yes. Now, string hash. So I use murmur hash 32, or murmur hash 3, the 32-bit version of that, as my string hashes in the engine. There might be some more recent and better versions, quite simply, these days. But I found actually on the Jai Discord, shout out to user Schwa, who had actually implemented Murmur 32 for us, because I found that was actually not part of the Jai sort of standard library or whatever. So let's try it out. Murmur 32.jai. I'm gonna just be copy pasting that there. Yeah, here's the link to the post. So shout out to Schwa for that. Let's see if it actually works. And the game engine actually verifies that the hash matches its own version of the hash in non-final builds. So we're gonna have a make string hash 1, and the string hashes by default just use the hash seed 0. So we can do make string hash, and that's a string, and it returns a string hash. I do not have the string hash here. Okay, let's just forward declare it to U32. So maybe I should be using a 64-bit hash. I don't really know. My games don't have perhaps that much stuff going on that there would be a lot of collisions or whatever, but maybe it would be good to have that. I don't think we should have any semicolons after the functions, right? And so we want a hash seed. That's how you make a constant, right? And then we do murmur 32. And that would be stir.data. And the length is stir.count. And then that's the hash seed. Like so. Does that actually build? No. Oh, I typoed that stir. Yeah. Okay, this is exciting. We're approaching the place where we can actually do things after quite a lot of work. So, now then, that is that. This should be a pointer. The hash is just by value, and that should be a pointer. And then why do we cast there? That shouldn't be necessary. That should be good. What? Oh. I need to cast that to a U32, don't I? Yes. Okay. Cool. Cool. That's it. That should be everything here in this file. Now, okay. The only thing we should need to do now then is these fix up things. So what we need to do here is basically convert this this Odin code here to the Jai version. It shouldn't be very difficult. Basically, we don't have that context there. We're probably gonna have to have a context here though, right? So let's uncomment that. Remove the fix up thingy. And that's a pointer. We don't have that. Actually, let's take all of that and replace it with that, because that's going to be the case everywhere. So we have factory interface pointer. Then we do new component. And then we return that. And now if we build this, it probably won't work. No, because we don't have a yes. So we need the push content, push context thing to happen. Yes. Okay, good. So that needs to be push context. Oh. Yeah, we need both of those. Okay, so let's do one at a time. Hello there, fellow The Language enjoyers. Yeah. I've been wondering about that. I get that John Blow isn't like a fan of, you know, people making a whole fuss about branding and whatnot, but I do feel it's a little silly not to like ever say the name of the thing you're creating. But, you know, to each their own and all of that. So let's see what we actually did here. We're hooking up now everything that we created to actually be called. Right? So if we create a new component, we get this factory interface thingy. Call new component on it, call delete component on it, update pre-tick and tick, and then a few of those things that get sent directly to the component. So create on object created draw editor, and that's it basically. We don't have the destroy here because that comes directly from the Jai code itself. Right? Okay. What do you guys think? Will this run? Will this run now? If we run the game, nothing will happen. Like, we're running the mod. Jai mod is loaded. And so we're running the code, but nothing is happening. And it is because we're not creating this thing. But now if we take a test component and we add that to something, we should see test component create called when we create it, test component destroy called when it's destroyed, and then we should see a whole bunch of ticks. Oh, here I'm actually missing a percent sign. Okay, let's try this out. So we're gonna need this string jai.test component, and let's add it to something. Let's add it to something that we don't have like a whole bunch of in the level. We have a gripper truck in the level. We have scouts in the level. We have... Yeah, we don't have a gripper. This is the old gripper. Let's add it to the old gripper. This is a vehicle that's very much like work in progress. I dislike that so much that I don't want to add it to the. Let's see. Do we have any other more sort of more special things here? Development blueprints. That looks good. Let's add it to one of the debug boxes. Right. Debug boxes 555. I don't think we have any of these in the level currently. So let's add a Jai component to this guy. We add a component here. We type this Jai.test component as the component type. It shows that it doesn't have any registered components of that type, but that's fine. And then we give it a name. Let's give it Jai comp or Jai test comp. And it tells us that it's not a registered component. Are you sure you want to use it? Yes, we're sure. Trust us, bro. And then whether or not we want to add it on the client or the server, I'm gonna add it only on the client now. Otherwise, we're gonna get like double of those outputs there. I'm gonna shut down the preview. And to top it off, I think that object type is one that we can just spawn here from this debug menu. Okay, so nothing yet. That means that we don't have any of those, but if we add a debug box... Oh, what do we have? Alright, so the call stack talks about Zig components. You can just pretend this says Jai here, because the C++ code kind of expects them to be Zig components, but they're not. So what do we have? On object created. Access violation executing location that. Okay. So we get this called correctly. On object created is not. It's probably that. Yeah, see, that pointer is not set to anything. On object created. Why do we not set that to something? What is going on? Do we really not do that? Component factory. Kind of looks like we're not. Oh, we're setting it twice. Okay. Yeah, that's the problem. So, on object created. There we go. Copy paste mistake. Also known as a whoopsie. Look at that. Now we're spamming and then we're destroying the thing. And so what do we have here now then? Okay, we have a little bit of confusing stuff. Some stuff to fix here. But like first of all, okay, we get test component create called. That's nice. So we're getting this. This is called. First of all. Then we have null component on object created called. That's actually fine. Because if we go to components, so that would be this guy. That guy gets called. We haven't overridden it, so it's completely fine that it's called here. Then we have test component tick called delta time something and some field 343. All of that is fine. This one though, I don't want null comp update to be called. So we're doing something wrong here with the update. So we're doing create. Oh, create. Okay, that's it. So what is that actually supposed to be? What are we testing for here on the Odin side? Let's have a look. Components. We're testing for update, pre-tick, tick, and draw editor. Yes. So that should be if update function is not null comp update, then we have. So we're setting the wrong flags there, quite simply. All right, we can't build. We don't have hot reloading for the for the mods, only for the main game. Here's my Jai code. Alright, so let's see if this is better now. Try to move that out of the way. And we get spawn an object and we delete the object. Yes, now this is much better. So if we don't override the tick update or pre-tick, we shouldn't actually call those functions ever, those you know, fallback functions, those null functions, these guys. The fact that it calls this null comp on object created, I think that's fine. That's just a single call, but we don't want to be calling those other ones. Just you know, spam them. So that's fine. If we took away, it's kind of flickering a little bit because I'm jumping between Visual Studios here. If we took away, let's say like the destroy here, just commented that out. Actually, we don't even need to do that. We can just comment out this assignment here. Now when we create, when we destroy the object, we should get a call to that fallback function, that null comp destroy function. Let's create boop, and then boop. Yeah, null comp destroy. So for the creation and the destruction, it calls those null functions. But for the updates, we don't want it to call anything. We just want it to chill, not do any of the stuff. That's good. Okay, so now we can. I'm just gonna actually comment out these things, and hopefully the compiler will be smart enough to realize that these functions don't actually do anything, and just remove them completely. But even if it doesn't really matter, because we're not going to be spamming them anyway. All right, that's pretty cool. So now we can create components. We can register them by basically doing this, and then here in the main.jai file, we just register one after another right here. That's pretty nice. I'm gonna take that away because that was testing stuff. I think I want my functions to look like that. So that's nice. It's working. And it is working now without any kind of function pointer table. Well, we have this is a V table essentially, but the actual component methods, if you will, they are now just normal function calls, not virtual function calls. So this is already better than the Odin one, although I'm sure it can be done with the Odin system as well. I just didn't quite figure out how to do it. I'm gonna take a quick break here, and now that we have the system working, let's actually do some fun little thing with it. Actually use Jai to do something in the game, because this was just like a whole bunch of figuring things out. Let's try to do something fun with it as the last thing this stream. But I'm gonna take like a 5 to 10 minute break. So let's put up a visual here and see you guys in a bit. Alrighty then. We are back. So, what should we do with our newfound Jai capability here in our little test component? That's a little loud maybe. Like we basically have, at least in theory, a lot of the core engine capabilities now available to us. We don't have a nice API to drive it from though. But like we can do a whole lot actually already. We can't play any sounds, we can't play any particle systems. None of that stuff. And perhaps most like the biggest problem here is that we can't send any messages yet. By the way, if we want to avoid the block of push context, you can use push context defer pop. Okay. Yeah. Okay. Yeah. I don't know. Thanks for the tip. I'm sure that'll be handy in some situations. I don't really know if it makes it any nicer looking in these simple cases. Anyway, what I was saying is that we don't have access to the so-called middleware yet. So basically everything that you see and hear here is stuff that I've made, and I have some sort of library for it. So for example, I have my own audio engine, and I have my own particle system engine, or particle engine, whatever. I haven't exposed those to Jai though, or any of the other languages that I've recently looked at. And we can't listen to messages yet. That would not necessarily be super tricky to add. I haven't done it for any of the other languages either. But yeah, we don't have that capability here yet. Depends on context. Hey! I see what you did there. Yeah, so a lot of stuff in this engine happens through messages. So if you have, what should we look at? This one maybe. Yeah. So here you have an interaction area component. And an interaction area component listens to messages on message received. A few of them we have here. Object transform updated and editor level loaded. It's actually a game engine, or sort of a level editor message, the other one. And then it destroys and recreates itself if it receives any of those messages, and then it can also send messages. I don't know if this guy sends anything. No, apparently not. But like that's how a lot of these components actually communicate, is through messages, and we haven't actually exposed that yet. To Jai. So it's a little limited what we can like just immediately do here. But what I was thinking is that we could do something kind of obvious here to at least see that, okay, we have the component there and it knows where it is in the world, and rather than just printing to the output, it would actually draw something in on the screen. So let's do something with debug drawing, because it's kind of easy to get going with debug drawing. So what do you say we do? Let's make a little thing where this thing actually like draws like a trail of where it has been, right? That should be kind of, that should at least like, it should require us to do a little bit of 3D math and actually like use this context to get its position, something like that. I think that'll be a pretty nice little closing of this stream. So what do we do? How do we do that sort of thing? Well, normally in Zig, if you wanted to get the object's position, you would use self.context.transform.getPosition or something like that. I don't remember the name off the top of my head. We don't have that kind of API yet. What we do have is basis dot is it component? Nope, it's not. Let's find it here in the huge list of function pointers. Get position, component context get position. Yeah, it is that thing. And component context get position takes an interrupt typed pointer and returns an interrupt vec3. So it's basis underscore component context get position, and it wants its self.cpp context pointer, and it wants actually let's do pos is of type basis dot interrupt vec3. I'm hoping this will now work, and it wants the address of that. That should be the way we actually get that position. And so let's print that position. And I'm sure we can do some fancy things here to make it easier to print these things, but for now we're just gonna do post.x, post.y, post.z. Does that build? Builds probably, but it can't write to the thing. Come on, there's my Jai code. There's my Jai code. That builds. So now it should be printing its position. If we kick around, I'm just gonna move this thing off to the side here, so that it doesn't keep flickering. Right, so we should be getting it here. If we spawn one of those things, we can see that, okay, we're getting the position. That's nice. And if we kick it around, it will also work. And if we spawn, let's say we spawn a gripper truck here, and we spawn one of those, oops, spawn it inside of the thing, set that as the avatar. You see it's kind of settled there, but now that we drive around, the position keeps updating. That's neat. And we are creating now, if we pause this thing, it stops printing. Update, if we put it in update rather than if we put it in update rather than in tick, this thing would now keep running, because we're still actually running the process here. We could move the camera and everything, but we're not ticking the game when we have it paused. And so because this is now running on the client, because we specifically mark this thing as being here on the client, we can actually use this thing to draw onto the screen. The server doesn't draw anything. You can technically draw if you force the server to run on the same thread as the client, but we don't do that currently. So let's make that thing draw some draw some trail of something after itself. So how do we do that then? Maybe we'll just quite simply have a positions field here, and that positions field should look like this, right? And then we have basis dot interop vec3. I would normally not use interop vec3s here, but rather have a nicer struct, like a vec3 struct with operator overloading and everything. But that will do for now. That's what the API expects of us. In some languages like SIG, for example, the interop vec3 can be very different from the actual vec3 that you use to write your gameplay code in terms of like memory layout and everything. I think in Jai they're probably going to be the same, but yeah, doesn't really matter. Anyway, so we have this guy, and maybe we'll want to have like the last position, right? Last pos is of type basis interop vec3 as well, and then we'll do something like, how does math work in Jai? I've never done any math ever. So we do something like what is it? Math like this. Can we go here and have a look? We can. All right, we have clamps, we have abscesses. Okay, that's nice. I think abs is actually what we want here. I don't even know what this syntax does here. I bet it lets us pass. Those are just integers. I want to clamp. I want to abs with floats. Oh, okay. Here we have abs float. Float 64, float 32. This is what I want actually. Good. Okay. So let's try that. So. So if, you know, self dot last pos x, so we're gonna do abs between last pos x and pos x is larger than something. Let's make a threshold here. Threshold. Whoop. Threshold is just, I don't know, 1, something like that, right? And y and z, right? So y and z. Whoops. Of course, we would have nicer sort of facilities for doing this stuff in the end. Does that by the way build? Nope. What do we have? So interop vec3 should be just a very simple little struct. Let's see where it's here. Interop vec3 xyz is float 32. Yeah. Procedure did not match any of the possible overloads. Float 32. Oh right, that's it's. I need to subtract them. There we go. Here we go. Okay, so now then we can do, what was it, array add, and we give it the self dot positions and pos, right? And then we do self dot last position equals pos. That's how it works. And then we get rid of this. Then we want another function here, actually. We want to do this in tick. That's completely fine, but we want to draw them in update. Otherwise, there might be some flickering on the screen that we don't like. Delta time, float 32. And of course, we need to do update function is update. There we go. So here we do for self dot positions, and that's not how you do it in Jai. You do it like this or something, and then we do basis dot debug draw, or whatever it's called. Let's find it. Debug draw. Well, actually, I can copy this stuff from the test code that I had previously. So let's look at it here. Here we go. Let's move that off to the side there. All right, so that draws a triangle and that draws a string. I think actually what I want is to draw a sphere. And so it wants the center, wants a radius, wants a color, and a point count. Whoops, let's not do that. Let's not break it. Draw sphere. Put that there in commented out form so that I can look up the parameters there, and then we actually need the name of it. The name of it is going to be debug draw sphere CB. CB stands for callback. And so we want to do address of it, I guess. And radius is going to be like, let's have it like quite small, so like 0.2. And then we want a color. So the color is actually the stuff that we can take from here. You can just do like, I don't know. Let's do like maybe a yellow or something. That would be 255, 255 color. Wants to pointer to that as well, and then point count is something pretty small, so we can have quite a lot of those, like 20. Let's maybe do 15. Okay, how about that? That needs to be basis dot. That also needs to be basis dot. And then, okay, what? Oh, no, that's a type. Yeah, again, the name of it is debug draw. The name of it is that. There we go. That should do it. Yes. Okay, so this is, of course, I would have to put in a little bit of work to actually make this nicer to use. But let's see, let's spawn one of those guys just on top of this thing. Oh, I'm getting just one. No, we're not getting just one, but something funky is going on here. Why aren't we not getting... Whoa. Let's go back to Jai here. do you say we actually just put in like a square distance function for those? Let's make a square distance, like square length function. Squared length, and we give it a vector, interop vec3, and it returns. I need to have the arrow there, float 32, and then we return v dot x times v dot x plus v dot y times v dot y plus v dot z plus times v dot z, right? That's a squared length of a vector, and then we'll do v is an interop vec3 dot, and then we'll do like essentially this, right? And then if squared length, so L is squared length of V, and then if L is like larger than threshold times threshold, because we're talking about the squared length here, then we add the thing. And that needs to be a basis dot and basis dot. And that needs to be one of those, whatever that's called. Okay, would that work better? Yeah, that works better. I want more of them though. Let's make the threshold half of what it is. And then we can put a gripper truck there. And spawn a bunch of guys into the back of the truck. Set it as our avatar. And oh, that's a weird sort of pause there. I don't know what that was about. But yeah, some beautiful Jai driven things. Maybe we should make those just like lines. It would also be faster to render if we have just like lots of them. You can see that it's running at a fixed rate, and that's a little strange. It's running at a fixed rate because it's running in tick, and of course it's not interpolated because we're just getting the position from it. Woink. Hey. Does work though. I think it'll be nicer looking if we just made it just a line. So let's maybe do that. Bonk. That should be easy enough, right? For that we need at least 2 of those guys. Let's see. So we have a line 3D. Line 3D is easy enough. It is one vector, another vector, one color, another color. So that should be easy enough to get working. Let's figure that out instead. So I'm gonna do something like self positions. So we do like if self positions dot count is larger than 1, then we do something. And then maybe I'll do this as just a manual. I'm so used to just hitting the parentheses after the for and the if that I do it just automatically. But let's do 0 to self dot positions dot count -1. Right? Hi, I noticed you commented on the fast compile times that you're not even using the fast compiler backend. Right, so I'm assuming you're talking about Jai now, right? You're talking about Jai rather than Zig, right? Because I've talked about the compile time for both of them. But yeah, that sounds good. Sounds good. So we're gonna do self positions data I -1, and then P1 is going to be self positions data I, right? Yeah, I mean it. If we can make it even faster, that's good. So what I said previously was that I really like the fact that this compiles so quickly. I have a little bit of a gripe with Zig currently, specifically on Windows. Their compile times are quite long. On Linux, you can use their self-hosted compiler, which does incremental compilations, which I know Jai doesn't do. Jai does the full compile, and that's nice. Anyway, the point is you get really fast compile times on like Linux, things like that. Not on Windows yet. And as far as I know, like that's mostly because LLVM is being slow. That said, even Zig would be fast with, you know, just this amount of code. So that's that's it, not I. Even Zig would be fast with this amount of code. And so I don't have any illusions that compile times would be slow with this. I don't know how long this is, maybe like a 3,000 or 4,000 lines. Most of those go into these few generated files though. Oh, this is actually already almost 2,000 lines, so maybe it's like 5,000 or 6,000 lines of Zig or Jai, sorry. But yeah, faster compilers sound good. Right, so okay, we're getting the first line there is from the world origin. That's a bit stupid, but yeah, let's not worry about that. We're just gonna do gripper truck, and then we're gonna spawn a bunch of these guys here. The lecture possessed 15,000 lines. That's interesting. Oh yeah, it actually shows them there. Okay. Here we have some nice looking lines. I don't know what that glitching was there earlier. That's kind of strange. You can see it like occasionally glitches. Is it maybe because we keep pushing lines to this thing or something. I don't know. I don't know. It's a bit weird. Occasionally we do get like a new... that kind of looks like it would be, you know... It happens seldom enough that it kind of looks like there would be some sort of like maybe expansion of the data. Allocating new memory for it and then it kind of glitches like that. Or I don't know. I don't exactly know. Okay, so let's yoink these guys up now. And we get this. We can draw in the air with this thing. Brrr. Bonk. Anyway, it's kind of working. Let's see. The LLVM backend is the default right now. You can use Jai X64 for the other backend. So which one is the fast one? Is the fast one the Jai X64 one? Pick up one of these guys and drive around with them. Brip, brip, brip. Oh. You know what? That's supposed to be... Oh, no, that should be fine. I wonder why I get those breaks in that update there. Well, that should be fine. Yeah, there's something wrong with my math here, clearly. And that's not really Jai's fault. X64 is the fast one, yes. Although it will generate less optimal code in some cases. That sounds very much like the Zig case, yeah. They're also using LLVM to do the really optimized stuff, and then their own backend for I think debug builds currently only at this point. Although I'm typically running the Zig code in debug mode because it's fast enough anyway. However, unfortunately, it doesn't work on Windows currently, only on Linux. So, eagerly awaiting that. At that point, my hot updating should be a lot nicer. Oh, hey, you're quite right. That's my math bug. See, I told you I had some math bug here. That's exactly right. More copy-paste errors. Thank you. Wouldn't starting to loop at index 1 be better? Maybe it would, yeah. Let's do that as well. Maybe that fixes the other. See, I'm just checking if you guys are awake. I know Xluxy just fixes all of my bugs. Yeah. It would definitely be better to start at the index we're expecting to start at. Let's actually try something here. Let's push the limits on this guy a little bit. We have a small test level here called crane development. this guy has a script on it where we can load dynamic objects, and we can have just like bunch of those. You can see there. And then we'll enable the cargo crane. Now we're gonna be lifting up just a whole bunch of those guys. Ah, look at that. And we're just painting the world yellow. Boink. Yeah. Thanks, folks. That fixed all of my my glitches here with the rendering. Anyway, I think we're pretty much done for today. Jai is officially working, as you can see. We can render things, and we can draw things, and we can do all of the things. Isn't that cool? And if we shut it off, they will fall to the ground and bounce around. Looks kind of fun, does it not? Pointed out the V assignment before. Yeah, you pointed out so many things. I'm aware. I'm aware and I'm grateful. Yes. Anyway, this is cool. So here we have a bunch of components now added to this object type. And so basically what we have in this one object type is components that are made in C++, components that are made in Jai. I'm not sure if that object type has any SIG components added to it, but it could have. And they're just kind of like working in harmony. The next step here would probably be to add support for messaging, and that way we could just do all kinds of things like react to when you collide with things, and just overall react to like events in the world. That's when you can get to like that's when you can really start to mess around with the environment here. And messaging would also be the main way that we would communicate with the components from the other languages, right? Because you can get pointers to components in the same language, but it doesn't really make sense to get a pointer to a Jai component from SIG, for example. Like none of the languages would understand what the other one is doing. And here now, if we start deleting these things, you can see that the lines also go away, because the memory for those lines is owned by the component. I don't think we actually necessarily get rid of that though. No, we don't. So what I will want to do here is self dot. Actually, is it free self dot positions dot data? There we go. Now we're no longer leaking memory. Yeah. Maybe we'll just boot straight into that level. Load dynamic objects like that. If I can remember my... Okay. Oh no, object got stuck. Yeah, it gets stuck between that physics object representing the claw and the actual cabin of the car. Let's see here. So if it has the create function, pass it through to create fn. Yeah, that's how I basically assign this. So create, and you tell it here. I have a create function. And this component tells the system, I have a create function. Call this when one of these guys are created. Call this when it's destroyed. And then update and tick. It's a pretty reasonable system, I think. Especially since we can do it without any kind of like indirection, like we don't have to run it through a function, a virtual function call or anything like that. I think that's kind of neat. Bonk. I mentioned metaprogramming. You could generate the boilerplate just by reading the test component struct. For example, passing the create function if the struct has a create function. Yeah, that's actually how I do it in Zig. So in Zig, you don't need to like tell the system anything. You just create like an update or create or whatever. And yes, I bet you could do that. I do kind of wonder what is the nicer way though. Like there's a little bit of documentation there in the fact that you actually like tell the system, hey, I want this thing to actually be called. I've been thinking about changing it in Zig, but I just haven't done it because I have like 30 or 40 different components there, so I would need to go in and actually change those. But yeah, I'm sure you could just like figure that out based on the type info or something. How does the Zig version of this work, since you can't just pass a function by pointer? We're not passing functions to Zig or to C++ or anything. Instead, we pass objects. We pass pointers to objects, and we pass those pointers as integers. Just int pointers. So let me quickly show you. Here, when we register this component, we call init component type. LSP doesn't let me go there directly, but we can find it here. So init component type is here. Here's where we pass all the functions that we potentially want to call. And then we make a component factory interface. And a component factory interface looks like this. It's essentially a virtual function table. We pass a pointer to this guy to the engine. So essentially out of Jai, and the engine gets the pointer as just an int, like a 64-bit unsigned integer. And then when we get that back, when the engine goes, okay, hey, I want to call update, for example, for this particular type of component, it gives us back this component factory interface. And we can see that, for example, here, if we go to C factory, update components. So this is called from the engine from outside Zig, outside Jai. cfactory update components, it gives us the factory interface int pointer, and that's just a U64. Then we take that and we cast it back to a pointer of one of these guys. And then we call update on it, which is here. And this update is going to be bound here. And here we know at compile time already the type of component that we are working with. So component factory of type T. And if we're on the client, we quite simply just call update function, which we have passed in here, which we also know at compile time, which is, of course, eventually what we pass here, which points to this guy. So by using one single, I should say, virtual function call, we can update every single instance of this type of component. So even though we have, I don't know how many of these dynamic objects here. What is that? That's 1, 2, 3. That's 6 times 6, so 36 times. What is that? 5. 5 times 36. I can't do math in my head. I can do that kind of math in my head at this time of day. 180 boxes. We do all of the updates for those with a single virtual function call. We cross the DLL boundary once for all of those 180 boxes. Brip. Yeah, you can almost like tip over, or you can actually tip over this entire vehicle. There's just so much force being applied on all of those objects there all at once. That's how it works. And it works the same way between Zig and C++ also, by the way. I've just like essentially taken that system and written a Jai version of it. But we don't pass any. Well, we do actually pass function pointers to C and C++ and Zig. Yes, we do that, but we pass them as just C function pointers. That's completely fine. Since you can't pass a function by pointer, absolutely you can pass a function by pointer. I do it everywhere. All right. This is these are all by pointer, right? So you can absolutely pass functions by pointer. That's what this entire system is built upon, actually. So for example, when we draw those lines, those yellow lines, we call this guy debug draw line 3D. And debug draw line 3D is found here. No, it's actually found here. Here we go. There it is. That's the function pointer, and it is of type this. And so you just need to add this C call here if you want to actually pass it to or from like a C library or a Zig library or or anything that communicates over the C ABI, right? So that's that. Anyway, I think we're pretty much done for today. This works well. Turned out pretty well, and it looks weird. It's kind of fun. I'll probably have to do a small little video of this thing for the Discord showcase. But yeah, we have Jai mod support. How cool is that? if you think this looks cool and you want to follow along the development of this game, whether that is in Jai or Zig or C++ or Odin or C3 or whatever else I come up with, be sure to subscribe. You can subscribe to this channel if you want to follow along with the live streams. There's also the link to the main channel, which is still significantly more popular because I just actually created this live stream channel. Or you can subscribe to both if you just want to stay on top of things. If you want to play the game, you can do so today. You can play Pre-Alpha 3, which is available both as a zip file and as a Steam playtest. You can do so by joining the Discord. There are links to both the Discord and the main channel, as well as the Steam page for Traction Point there in the beginning of the chat. And also in the description below. So, join the Discord if you want to play. And if you don't mind, I would appreciate it if you went and added the game to your wishlist on Steam, because that way Valve gets excited about the game in various ways. So it really helps. And yeah, I think that's it. Other than that, have an excellent rest of your day. See you next time, maybe.